Hi again, this is Brooke Cologne, again for homework 5, question 2 for EL6303. That's up here, alright? So, I'm just going to go through this quickly since I know the videos are a little long. We are given f of xy is equal to 1 over a y squared times x. And when y is greater than or equal to 1, and 1 over when x is between 1 over y and y. So the first part that we have is to draw the non-zero definition region of f of xy. Okay, so let's do that. So we have x equal when x equals y. Okay, so this is for x equals y, and then we have this for x equals 1 over y. Now we have to draw the region where y is greater than or equal to 1 and x is greater than 1 over y. And that includes this region here. Alright, so that's question 1. Now we're going to go into question 2, which is find a so that f of xy is a valid joint density function. So again, let's write that y is greater than or equal to 1 and x is in between 1 over y. X is in between 1 over y and y. So we have from 1 to infinity, from 1 over y to y of 1 over ay squared x dx dy equals 1. So I move this up. And so as we work through this, 1 to infinity, 1 over ay squared over y to y, 1 over x dx dy equals 1. It's all basic math here. ln of y minus ln 1 over y dy equals 1. And so this is just -1, so it's just 2 ln of y over a y squared dy equals 1. And from here, 2 over a equals 1, which leads to a equals 2. So there you go. And then, we have our third, move this up. Our third problem is that find and draw the marginal density functions fx and fy. So, let's see, fx is equal to -infinity to infinity f of xy dy, and y is greater than 1. So we have 0 is less than 1 over y is less than or equal to 1. And when x is greater than 0 but less than 1, f of x equals from 1 over x to infinity 1 over 2y squared x dx and is equal to 1 over 2. And from when x is between 1 and infinity, we have equals x to infinity, 1 over 2y squared x dx, 1 over 2x squared. So, oh, my bad. I had a hard time seeing that. Sorry. And so, f of x is 1/2 0 to x1. And for 2x squared, when x is between 1 to infinity. Okay, and for fy, we're actually going to have to move up on the page. And I'll move this over so that you can see. So 3 continued. We have f of y equals negative infinity to infinity, f x y dy equals y, from 1 over y to y, 1 over 2y squared x dx equals ln of y over y squared. Put this over so you can see. From when y is between 1 and infinity, and 0 otherwise. So now we move on to 4, which is asking us to verify fx and fy as valid density functions. Now this is relatively straightforward. So let me see that you can, there you go. And so let's verify y. So from 1 to infinity, we have ln of y over y squared, because this is, again, 0 otherwise, and this is a function, oh, excuse me. Oh, wow. This is a function that we're dealing with here. And so that's the one we need to verify. And so run through this, and we know that this is equal to 1. So therefore, fy is a valid probability function. And so for fx, we showed earlier that is 1 over 2 between 0 and 1, so this is fine. We just need to figure out if this is alright. So we do f of x, let's rewrite this so you can see it, over 2, 1 over 2x squared, 0, 1, 1, x infinity. So from 1 to infinity, 1 over 2x squared dx equals 1 over negative 2x between 1 and infinity, and this is equal to 1 over 2. Now from negative infinity to infinity, we have f of x equals 1 over 2 plus 1 over 2 equals 1. And again, so f of x is also a valid probability density function. So, there you go. All right.